Alright, you guys, so I just wanted to give you a couple of examples for some extra practice working with matrices. So I'm going to start with some examples on finding the size of a matrix. So to find the size of the matrix, we count the number of rows and columns that that matrix has. So if we had this matrix, to find the size, we're looking at the number of rows. So there's a row here and a row here, which means there are 2 rows. So when we write the size, that would be the first number. Then we look at the number of columns. So there's a column here, and a column here. So 3 columns total. So that's going to be our second number in the size of our matrix. And then between that, we put this X to tell us it is a 2 by 3 matrix. All right, let's look at another one. All right, so if we had this matrix, to find the size of the matrix, we first count the number of rows. So there are 1, 2, 3 rows. Then we count the number of columns. And in this matrix, there are 1, 2, 3 columns. So this matrix would be a 3 by 3. All right. Now let's look at some examples of how to find a specific entry in the matrix. So say this matrix was called A. If we wanted to find a certain entry, then we would see something that looks like this. So A21. That tells us we need to go look in matrix A, and then we need to go to the second row in the first column. So the first number is the row, the second number is the column. So we need to go to the second row, which is here, and then the first column, which is here. So we're looking for where this row and where this column intersect. And when we look for that intersection, we see that we're at this number right here. So A21 in this problem would be a 4. All right, so let's try another one with the same matrix. So say we were looking for A32. So A32 tells us we're looking in matrix A. 3 is the row we're looking for, so the rows go this way. The third row is this bottom row. So we need to look at row 3, and then the second number tells us the column. So we need to look at column 2. So we need to come not to the first column, but here to the second column. So our answer is going to be in this column and in this row. So when we are in row 3, column 2, we're at this number right here, 7. So A32 would be a 7. All right, so that was a little bit of extra work with finding the size of a matrix and finding specific entries in a matrix. Next, I want to work a few more adding and subtracting problems with you guys. So if we want to add these matrices together, let me go ahead and write them out. All right, so say we have this problem here. We want to add these 2 matrices together. So we need to check the size of both matrices. So we're going to look at the first matrix and figure out its size. So this matrix has 1, 2 rows, and then 1, 2, 3, 4 columns. So this is a 2 by 4 matrix. Coming over to this one, it has 1, 2 rows, and then 1, 2, 3, 4 columns. So this would be a 2 by 4 matrix as well. So because these are the same size, then when we add them, we can go ahead and add the entries that are in the same spots. So this goes back to what we just did with entries and their locations. So this entry right here is in the place 1, 1. It's in the first row and the first column. So when we try and add the matrix to the other matrix, we need to add the number over here that's in the first row and in the first column. So they have to be in the same position. So we're going to add 2 plus 5, and that will go in the same position, that first spot in our answer. So 2 plus 5 is 7. Next, I move over to the right. I'm now still in the first row, but I moved over to this second column here. So I have a 1 plus, over here I need to stay in the first row, but go over to the second column, so 9. 1 plus 9 is 10. All right, next I move over to the right again to this 3. So first row, third column, plus, over here, first row, third column is negative 1. 3 plus negative 1 is 2. And then finally, the last number on our first row is a 7 over in column 4. So 7 plus the number over here in the same spot is 0, and 7 plus 0 would give us 7. So then when we go to do the bottom row, we're following those same steps. We're going to do negative 3 plus, over here, negative 6 is in the same spot. Negative 3 plus negative 6 would give us negative 9. Next, we have 1 plus the one in the same spot is 7. 1 plus 7 gives us 8. Next, we move over to this 9, and we add the number that's in the same position. So 9 plus 4, and 9 plus 4 gives us 13. So we write that in the same position. And then the last number in the second column over here in the fourth row is 11. So we're going to do 11 plus, over here we have negative 13. And 11 plus negative 13 is going to give us negative 2. So then this would be our final answer, this matrix that we have right here. 7, 10, 2, 7, negative 9, 8, 13, negative 2. All right, so that was an example of adding two matrices together. We're also going to look at an example of subtracting. So let's start with this matrix. So 3, 2, 1, 1, 5, 3, negative 1, negative 5, negative 7, minus there we go. So minus negative 5, negative 11, 6, negative 1, 5, 11, 2, 4, 9. So we're going to subtract these two matrices. And when we subtract, we still have to follow the same rules that we did when we added. But when we go to do the combination with the two matrices, instead of adding the same entries, we're going to subtract them. But rule 1, we still have to check the sizes. So over here, we need to know the number of rows and the number of columns. So the number of rows, there are 1, 2, 3 rows. 3 rows here. And then there are 1, 2, 3 columns. 1, 2, 3 columns. So the first matrix is a 3 by 3. Now over here, there are 1, 2, 3 rows and 1, 2, 3 columns. So that would also be a 3 by 3 matrix. So because these are the same size, we are going to be able to subtract them. And when we go to subtract them, we subtract entries that are in the same positions. So when we start with this 3, we need to subtract this negative 5. So 3 minus negative 5 for our answer gives us 8. Next, we need to do 2 minus, and then the number in the same position is negative 11. And 2 minus negative 11 is the same as 2 plus 11, which gives us 13. And then finally, for our top row, we have a 1 minus the number in the same position over here is 6. And 1 minus 6 is negative 5. All right, so that's row 1 all done. Next, we move on to row 2 and start with that first entry in row 2. So 1 minus the same entry over here would be negative 1. And 1 minus negative 1 is a positive 2. Next, we move over to the 5, and we have 5 minus 5 for that same location entry. So that gives us a 0. And then the last entry in row 2 is 3. So we're going to do 3 minus the last entry in row 2 over here is 11. So 3 minus 11. And 3 minus 11 would give us negative 8. So we've done row 2. Now we move on to row 3. So row 3, our first entry is a -1. So we do -1 minus the first entry in row 3 over here is a 2. -1 minus 2 is -3. Next we move over to -5. So -5 minus 4. -5 minus 4 is -9. And then our very last entry, the entry in the third row in the third column, is -7 minus over here, third row, third column, 9. So -7 minus 9, and -7 minus 9 would give us -16. So this matrix right here would be our final answer. Alright, so that's just a couple of extra examples for you guys on using some of these properties we've talked about with matrices.